Welcome to this first lesson on algebraic fractions. This will be an introduction to algebraic fractions and looking at the most basic operations that we can do with them. Hopefully, coming into this lesson, hopefully that you've seen indices 1 and 2, because that will be very useful for you, and you've managed to download the worksheets and have a go at them. We'll start, as always, by going through the solutions to these worksheets, or these starter questions. And the first one says, simplified 12x to the power 5 y to the power 4 over 3x y to the minus 2. So we looked at this in depthly when we looked at indices. So the first thing we need to do is break these down into the whole numbers, the x's and the y's. Okay, and we're going to use basic maths understanding and our indice laws to do this. The first thing you should have done is 12 divided by 3 is simply 4. X to the power 5 divided by x, well, the first thing you should do is you should fill in that if there is no power it is 1, and the rule when we divide bases that are the same, we take away the power. So we're going to do 5 minus 1, which would be simply x to the power 4. And then you just have to be a little bit careful on the y, so the base will stay the same, y, and we're going to do 4 minus minus 2. Well, 4 minus minus 2, remember, would mean plus, so that would be 4 plus 2, which is 6. So the final answer to question number 1 would be 4xy, that's 4x to the power 4, y to the power 6. Moving on to the top right question. Is a surds question. So again, if you are following along with these lessons, this is another topic that higher year 9 and higher year 10 and GCSE higher should have looked at. When we need to simplify the surd, we have got a surd on the denominator, so you should be thinking, I need to rationalize this. And again, if you don't know what I'm talking about, go back and look at surds. To do that, remember you times by root 3 on the bottom, because root 3 times root 3 cancels the surd and would leave you with 3. And you have to do the same to the top given a basic fraction rule. Okay, whatever you do to the bottom, you have to do the same to the top. So timesing across here would give me 3 root 3 over root 3 times root 3 is 3. And then what you can see, again, basic fraction understanding, those 3's can cancel. So my final answer to this is simply root 3. Moving on to the bottom left, we're going to be looking at multiplying and dividing fractions today, so I'll put this in just for a recap to make you think about it. First thing you should notice here is we've got two mixed numbers and we need to change them. So we're going to change these to top heavy. So 3 times 2 is 6, plus 1 is 7 over the original denominator 3. Times by changing this one, 5 times 3 is 15, plus 2 is 17 over 5. Okay. Now we can simply multiply across, which wasn't very nice. You got to do 7 times 17. So again, if you don't have a calculator, you would do 17 multiplied by 7, and you'd have to do this in an exam. 7 sevens are 49, so you carry the 4. 7 times 1 is 7, plus the 4 is 11. So that would be 119. So we've got 119 over 3 times 5 is 15. This is top heavy, so we need to change it to a mixed. So we need to know our 15 times table, because we need to know how many 15s go into 119. Well, the easiest way is just write it out: 15, 30, 45, 60, 75, 90, 105, and then 120. 120 is too many, so it goes in 1, 2, 3, 4, 5, 6, 7 times whole over 15. And what do you have left over? Well, how do you get from the last multiple, which is 105, to 119? You would add 14. So it would be 7 whole ones and 14 over 15. And again, this is something that you need to be really comfortable with. Easy marks in an exam paper, and it will always come up in some sort of fashion. So moving over to the next question, just a very basic divide. What do you need to know when you divide fractions? KCF. Keep, change, flip. Okay, we're going to keep the first fraction, so we're going to leave it as 5/8. We're going to change the divide to a times, and we're going to do the reciprocal, flip the last fraction. So KCF is in that order, keep, change, flip. Now it's easy, you just times across, so 5 times 2 is 10, 8 times 1 is 8. Again, top heavy, how many times does 8 go into 10 whole? 1 whole 1 with 2 8s left over. We're not quite done because we can simplify this. That would go to 1 whole 1 and 2 8s simplified to a quarter. So the answer, the most simplified version of that question would be 1 1/4. So this takes us nicely into the beginnings of algebraic fractions. So often viewed as quite a difficult topic by students, but what is algebraic fractions? It is just a extension of fractions. So if you are confident with basic fractions, fraction operations and basic algebra, it is just taking all of that and combining it. So what I've written here for you is the prior knowledge that you need to have a secure understanding on to be able to successfully do algebraic fractions is basic fractions. So what do I mean by that? I mean, you need to be able to simplify. So again, if there's any areas where you can't do any of this, you need to think, I need to go and make sure I'm good at that so I can really nail down the algebraic fraction stuff. So you need to be able to simplify, and something called cross cancel, which is a technique we will be looking at today. Basic fraction operations, so that is just adding, minusing, timesing and dividing. Basic algebra, so multiplying, okay, factorizing is something you need to be able to do, and solving an equation. We know how to solve an equation, hopefully. So if providing you know how to do these 4 areas, algebraic fractions is just an extension of those where you combine them together. So we'll start by looking at how do we simplify algebraic fractions. Well, this works providing everything is multiplied together. You can cancel, and we've seen this, but this is just laws of indices. So we've already looked at laws of indices over the course of 2 lessons, and it's basically that. As you can see, example 1, everything's being multiplied together. You've got 5xy, that means it's all times together over 10x. That's all times together, so we can just cancel here. So what we can do is essentially use our laws of indices. Well, we know that we could cancel 5 and 10 would go to a half, so that would be a half. And then technically this is x to the power 1 divided by x to the power 1. Well, that would be 1 take away 1 is 0, and x to the power 0 is simply 1. However, at this point, you should be advanced enough to think, right, x's, they cancel, so I can cancel those x's off. So I'm just left with 1/2 y. The 5/10 goes to a half. The x's cancel. Yeah, and the reason they cancel is due to the fact they go to x to the power 0, which is 1, but simply they just cancel. And then you've got a y on its own, so you've got a half y. There's many ways you could write that. Another way you could write that is y over 2. You should be really familiar with the different formats in which you can write fractional terms, but they are the same thing. So going into example 2, very, very similar. And I'm just going to go through this fairly quickly because a lot of this has already been covered in indices 1 and 2. Here we can cancel the 6 and the 4. What goes into 6 and 4? 2. 2 goes into 6 3 times, and 2 goes into 4 2 times. I can then cancel my a's. And then this here, we've got b times b. b squared means b times b. So we've got 2 b's, and we've got 1 b here. So we can cancel off a b. So essentially we can cancel off the squared, which would get rid of one of the b's, and cancel off that b there. So what we're left with here, we're left with 3/2. A's are gone, the b on the top's gone, but there's 1 b left over on the bottom. And just to really illustrate why that is, this is b times b on the bottom, because b squared means b times b. You've got b on top, and we can just cancel that b with one of those b's, which would leave me with 1b on the bottom. So I need to make sure this b comes on the bottom. So we've got, our final answer is 3 over 2b. Again, the a's cancelled. Example 3. Similar story, right? If I look at I've got 100 here, but I've got no number here. Technically there's 1, but you can't really simplify 101, it just stays 100. We've got x squared and x squared. Well, they're both x squared, so we can cancel off the x squareds. And then we've got y cubed divided by y squared. Well, we know that we can minus the powers. If you divide bases of the same, you can minus the powers. So 3 minus 2 would be y to the power 1. Essentially, what we're doing is cancelling off those two and leaving this with 1. So that is simply 100 to the 100y to the power 1. And again, to illustrate, y is this. You've got y times y there. You've got 3 y's here because it's cubed. 2 of these can be cancelled with 2 of these, which leaves you with 1. Or we know that the indice law states that 3 minus 2 is the rule, which would just be 1, and we don't write 1. Okay. So that is essentially just looking again at indice laws. And again, if you want a more in-depth sort of video series on why what I've just done works, go and look at indices 1 and 2. So this takes us now on to the main part of this lesson, or one of the main parts I should say, which is multiplying algebraic fractions. So the first thing that we just need to recall is, how do we multiply a basic fraction? Well, if you have a fraction times by another fraction, we know, hopefully, you simply just multiply across, yeah? You just do the top times the top and the bottom times the bottom. So you could just put here, if you want to, example, 2/3 times by 1/2, well, let's not say 1/2, let's say 1/5, would be 2 times 1 is 2, 3 times 5 is 15. So you simply just multiply across. So we can take this understanding into algebraic fractions. It's just the same, it's just you have algebra instead of strictly numbers. Example 1. We've got 4/3 multiplied by a over b. Well, in what we just discussed was, times in fractions, you multiply across. So we can multiply across. So 4 times a is 4a, 3 times b is 3b. Again, and that relies you knowing that 4 times a can be written as 4a, which hopefully you do. And that's it, there's no simplifying here. We cut, like 4 and 3 can't be simplified. A and b are not the same term, it's not the same base, so you can't start cancelling that down. So our final answer to that is simply that, 4a over 3b. Example 2. So what I'm going to start to explore now is how can we do something called cross-cancel. Okay, and I'll explain this in my fraction series, cross-cancel. Cross-cancelling is the quickest way to multiply fractions. It only works when you multiply fractions. You can only do this cross-cancelling technique when you're multiplying fractions. And how it works is you can check the diagonals to see if there's anything that can be cancelled. So if we check this diagonal here, I can see that they both share an x. So I could cancel off those x's. Okay, before I even start to multiply these fractions, I can see if I check the diagonals, they both share an x, one x, so I just cancel it off. Again, this only works when multiplying. If I check the other diagonal, well, that's a y and that's a 4. There's nothing that can be cancelled there. Yeah? There's no 4 or 8 that can be cancelled. There's no y up here, so we can't cancel anything. Cross-cancelling, sometimes you can't do it. The previous example, if I check the diagonals, nothing can be cross-cancelled there, and nothing can be cross-cancelled there. So sometimes you can't do it, but it is worth checking. So if I cancel those two x's, I'm technically leaving, if I get rid of this x here, I'm technically leaving it with 1. Yeah. If I get rid of the x, I'm leaving it with 1. Now I can do my fraction rules. I can multiply across. 1 times by 4 is 4. And y times by 6 is 6y. Now hopefully you can spot there. If that y wasn't there, hopefully you would cancel that fraction. So what goes into 6 and 4? It would have been 2. 2 goes into 4 twice, and 2 goes into 6 3 times. So my answer to this, as simple as possible, is 2 over 3y. Now you might be thinking, why didn't he cancel it here? You could have cancelled it here. I just didn't want to overwhelm you on top of the cross cancelling. So you could have cancelled it here. You could have said, right, I can see 4 and 6, given my basic fraction understanding, 4 and 6 could be simplified to 2 and 3. Then if I multiplied across, I'd do 1 times 2 is 2, and y times the new 3, which we cancelled, is 3y. So if I cancelled earlier, I would have got the answer straight away. But I just didn't want to throw it in there and confuse you. But you'll see as I progress, I start to do multiple things at once. Okay. Alternatively, if you do not like the cross cancelling, let's just see what happens if we didn't cross cancel. So if I do an exam, the same question with no cross cancel, not using that method, what would I do? I've got x over y times by 4 over 6x. Well, if I just times the cross, that would give me 4x, because x times 4 is 4x. And 6x times y is 6xy. And then you can see, now you should be able to see that you can cancel. 4 and 6 can be cancelled to 2 over 3. The x and the x cancel, and we're left with the y on the bottom. So you get the same answer. Both methods, one is not better than the other, but the more you practice cross-cancelling, the more you should see that it will make things easier for you, providing you understand it. And we'll look at it a lot today. But either way, if you decided you didn't like the cross-cancelling, you could just do it the long way and then cancel at the end. Whichever way you would like to do it will get you the right answer, providing you're careful. Example 3. So I'm going to do the cross-cancelling method here. I'm going to check my diagonals. I've got 6x and 5. Nothing can be cross-cancelled there. 6 and 5 don't share a factor, so I can't cancel that. And there's an x here, and there's no x's down here. So I can't cross-cancel. If I check the other diagonal though, and again this only works when multiplying, I can see 2 and 4 share a factor of 2. So I could cancel this 2. How many 2's go into 2? 1. I could cancel this 4. How many 2's go into 4? 2. Because they share 2, I'm putting 2 into both. Much like normal simplifying a fraction. And they also share a y. This has 1y and this has 1y. So we can just cancel those off. Which now just makes my multiplying quicker. I've got 6x times 2. Well, that would be 12x over 1, because I cancelled these two things and left it with 1, times by 5 is 5. So my answer to that is 12x over 5. Alternatively, again, just for the notes, well, let's not write notes, let's write non-cross cancelling. So we'll show you the method again with no cross cancelling. Okay, so non-cross cancel. What would that give us? Well, we would have 6x over 2y times by 4y over 5. So if you don't like the cross cancelling, you can still just multiply across. You just have to be careful. 6 times 4 is 24. And then x times y is xy over 2y times 5 would be 10y. And now we need to see if we can simplify. So you can see that 24 and 10 share a factor of 2, which would be 12 goes into 24 twice. The y's will cancel. The x's won't, so we have x on top And how many 2's go into 10? 5. So again, you get the same answer. But if you can get into the habit of cross-cancelling, providing you understand it, it does actually make it easier, in my opinion. It looks harder, but when you understand it, it is easier and quicker. But as you can see, whichever way you decide to go about it, providing you follow the correct procedures, you'll get the right answer. Either way. So example 4. Example 4 says we have got 8u over u, w, times by w squared over 16u. So if I check my diagonals, I've got 8u and 16u. Well, the first thing I can spot is I can get rid of the u's, they cancel. Okay. The next thing I spot is 8 and 16 share a factor. What is the biggest thing they share? 8. So I cancel this 8. How many 8's go into 8? 1. How many 8's go into 16? 2. So I leave that with a 2. If I check my next diagonal, I've got uw and w squared. So again, that w squared means w times w, and there's one w here. So they share one w I cancel. So I could cancel off this squared and leave it with 1w, and I can cancel off this w. What does that give me? That gives me now 1 times by w is w over u times by 2, which is 2u. So as you can see, it gets you to the cross-cancelling as a way to get to the complete simplified answer in almost one step. Again, just for your notes, let's look at if we didn't cross-cancel, so no cross-cancelling. And you don't have to do both methods, obviously. You pick one and you just use it. What would that look like? It would say 8u times by w squared over uw and 16u. So if I times across, 8u times w squared would give me 8uw squared over uw times 16u. Well, the u times the u would be u squared, so you'd end up with 16u squared w. U and u make u squared. And now you'd have to cancel. So as you can see, this is a longer process. Now I have to check. Right, 18 and 16 is a half. This u can be cancelled with one of these squareds because a squared means two of them. And this w can be cancelled with this w. Again, using indice laws is what I'm doing there. That's technically the power 1. 2 take away 1, it would leave me with 1w. So what am I left with there? I'm left with 1w over 2u. So either way, we achieved the same answer. Okay, moving on to example 5. Here we've got 3 algebraic fractions being multiplied together. So we can check the diagonals of those two, much like we can check the diagonals of these two. And we can see if we can cross cancel. Well, this 4 and this x, I can spot, they could be cancelled. The cross-cancelling method, they can be cancelled. So I can see that this 4 and this 8 share a factor of 4. So I could cancel this 4 with 4, which would leave me with 1, because 1, 4 goes into 4. I can see that this 8 has a factor of the same 4, which would leave it with 2. And I can see the x's cancel as well, so I can get rid of those x's. If I now check my y with the diagonals up here, I can see there's a y here which I could cancel. So I could cancel this y and leave it with 1, and this y to leave it with 3. So what does that give me? Well, now I can just multiply straight across. I've got 1 times by 3, which is 3, times by u, which is 3u. So that would give me 3u. over 1 times 2 is 2 times by v is 2v. And that is my most simplified answer. So you can see cross-cancelling helps us. And just for completion, we'll do in blue, we'll do what would happen if I didn't cross-cancel. What would I get? Well, I've got 4x over y times by 3y over 8x times by u over v. So if I did not cross-cancel, I would have to multiply straight across. So I'd have 4x times by 3y would give me 12xy, times by a u would give me 12xyu. So on the top I'd have 12xyu over y times by 8x would be 8xy, times by a v would give me 8xyv. So I'd have 8xyv. And now we would have to simplify. So if I simplified this, I would see that 12 and 8 share a factor of 4, which would be 3 over 2. The x's can cancel to nothing. The y's can cancel to nothing. And the u and the v can't cancel because they're different, right? So what do we end up with here? We end up with 3u, yeah, because we got the 3 and the u on top, and just the 2v left on the bottom. And again, same answer. So whichever way you go about it, whether you cross-cancel or do not cross-cancel, you will end up with the same answer. So I just wanted to illustrate there both methods, so you can decide which one you prefer, because sometimes students can see it one way and find it really easy, and then other times other students find it completely impossible to do the cross-cancelling method, or vice versa. So you get to decide which one you prefer. If you're watching it live, you can come back to it at the end. If you're watching it on playback, you can pause the video, have a go, and then move on. But I'll put the link to the answers below, as well as further questions that you can practice with answers. So there's plenty of practice you can do, but just for the time length of this lesson, we'll leave those that you can practice alone, and we'll move on to dividing algebraic fractions. Okay, so dividing algebraic fractions. If you note back in the starter, and generally if you know about basic fractions, because to be able to access all of these different sections of algebraic fractions, you need basic fraction understandings. What do we know about dividing a fraction? We know that you keep, flip, and change. Okay, or the other way around, sorry. You keep, change, and flip. You keep, change, and flip. So if I had 2 over 3 times by 1 over 5, I would keep the first one. I would change. I don't know why I've written times there. That should say divide. I would change the divide into a times. So we'll write that. The divide will change into a times. And I would flip the last fraction. Okay, so I'd flip the last fraction. So what would that give me? It would give me, so this would equal 2/3, keep that, change, flip the divide, change the divide to a times, and then flip the last fraction. So that would be, and we know this, when you times fractions, you just times across, we've just looked at it. So it'd give me 10 over 3. So hopefully you can sort of see where this is going. If you know how to times algebraic fractions, which we've just done, when you divide them, the only extra step is you need to flip or do the reciprocal of the end fraction and change the sign to a times. Okay, so example 1. It says a over b divided by a over b. Well, the first thing we need to do is KCF. We need to keep, change, flip. We're going to keep, change to a times, and flip. If we flip a over b, we get b over a. Now we know how to times algebraic fractions because we've just looked at it, and hopefully you've practiced it as well. So if I times these together, I'm going to do the cross-cancelling method. From this point out, I'm going to just do cross-cancelling because it's arguably the quickest and simplest way to get the final answer. I'm going to check my diagonals because it only works when you times, remember. What a lot of students do is they try and cross-cancel all the time. They think they can do it whenever they want. You can only do it when you're multiplying. So we're now multiplying, which means we can cross-cancel. So if I check my diagonals, I've got an A and an A, so they can cancel, leaving me with 1 there and 1 there. And if I check my other diagonal, I've got a B, they can cancel. So a B and a B, leaving it with 1 and 1. So what does this question actually say? It says 1 times by 1, which is 1, over 1 times by 1, which is 1. So 1 over 1, well, that is simply 1. So the whole answer to that question is just 1, because we have to flip and times, and then we can cross cancel. Okay. Alternatively, if you didn't cross cancel, you'd have A times B is AB over B times A is BA, and the A's cancel and the B's cancel, so you'd be left with just 1. So either way, you should get 1. On the next one, example 2. Again, KCF. We're going to keep the first one, which is 3x squared over y. We're going to change the divide to a times, and we're going to flip. So we're going to get y cubed over 6x squared. And this is where cross-cancelling can be useful and save you time. I'm going to check my diagonals. I've got 3x squared and a 6x squared. Well, 3 can be cancelled because 3 goes into 3 once and 3 goes into 6 twice. And I've got x squared and x squared, so they can cancel. Checking this diagonal, I've got 1y here and 3 y's here. So if I get rid of one of these y's, I have to get rid of one of these y's, so I'd leave that with 2. And again, indice laws state that if I do this divided by this, I do 3, take away the power 1, which isn't written but is actually there, and 3 take away 1 is 2. Okay. So now I can times across. And it looks messy, but we've got 1 times by y squared, which is y squared, over, if I got rid of, I should have, it's bad of me, I should have written a 1 here. If I get rid of that y and there's nothing there, I'm leaving it with 1, technically. So I've got 1 times by 2, which is just 2. So my answer to this whole question is y squared over 2. So as you can see, we have used the basic fraction division operation law, which is you do the reciprocal and you multiply. And then we've used some cross-cancelling indice laws to get the final answer. On the next one, example 3. So we've got 2 more examples. Example 3. So this is where things get a little bit more interesting. We've got 8a over b divided by 8b over a squared, and then we need to times it by 3a over b. So the first thing we're going to do is focus on the division. Yeah, if you think about BIDMAS, division comes before multiplication. So we're going to focus on the division first. So if we do that, what do we end up with? We end up with 8a over b times by, remember, KCF, keep, change, flip, keep, change, flip. We're going to do the reciprocal of this last fraction, which would be a squared over 8b. And then we've still got the times by 3a over b. Well, we've seen in previous examples that we can now, because they're all being times together, we can just run across, look at all of our diagonals, and see if there's any opportunity for cross-cancelling to make our life easier. So, I've got a b down here, and I've got an a squared here, and a 3a here. There is absolutely no opportunity for us to cross-cancel. There is no common factor, either numbers or letters, so can't cross-cancel there. Here I've got 8a, and I've got 8b and b. Again, there's nothing that we can cross-cancel with. Okay, Absolutely nothing. So we can't cross-cancel it. So it's an example where cross-cancelling cannot be applied. So we have to simply multiply across and collect all the terms together. So we've got 8a times by a squared, which is 8a cubed, times by another 3a. So if I times that by 3a, 8 times 3 is 24, and a cubed times by a is a4. And the reason for that, remember, is technically there's a power 1 on this a. And when you have the same base of a and you're timesing, the rule says we add the powers. So 3 add 1 is 4. But you should just know that a cubed times by a is a to the power 4. So on top, I'm going to get 24a to the power 4. On the bottom, I'm going to do b times by 8b, which is 8b squared, times by another b, which would be 8b cubed. So on the bottom, I'm going to have 8b cubed. And I can just see that I was a bit silly. I didn't spot somehow. I could have cancelled those 8s. I could have cross-cancelled those. So if you spotted that, well done. I should have really cancelled those 8s to make my life easier. But as you can see here, we can now we can cancel what goes into 24 and 8, or 8 does. 8 goes into 24 3 times, and 8 goes into 8 once. So my final answer to this is 3a to the power 4 over b cubed. So I managed to miss a cross-cancelling there, and sometimes that happens. But as you can see, I still followed out my other method, the original long method, correctly, and I still got the right answer. Because if you think, if I cancelled this 8 with this 8, I would have just negated the 24 and the 8 and just had a 3 here, because there would have been a 3 there. So I missed it, but I still got the same answer. Okay. So moving on to example 4. We're going to do 10u to the power 5 v to the power 6 divided by 3a squared, all divided by 5uv over a to the power 5. So we're going to do the KCF. We're going to keep 10u to the power 5 v to the power 6 over 3a squared. And we're going to times it. We're going to change it to times, and we're going to flip. We're going to do the reciprocal, which would give me a to the power 5 over 5uv. Let's see if we can do some cross-cancelling now, and hopefully don't miss anything. If I check this diagonal with this diagonal, and again, it only works when we're timesing, I can see I've got 10 and 5, where I know I can cancel 5 goes into 10 twice, and 5 goes into 5 once. I've got a u to the power 5 here, and a u down here. So I've technically got a u to the power 1. So a u5 divided by a u1. You minus the powers, or essentially you cancel that, and we're going to leave this with a 4, because I'm cancelling off 1. And then the same thing with the v. I've got a v6 and a v. Well, this v can cancel with one of these v's to leave it with a 5. And if I check this diagonal with this diagonal, I can see I've got an a to the power 5 here and an a to the power 2 here. Well, I could get rid of both of those two a's. And if I take off 2 of these a's, I'd be leaving myself with 3 here. So again, you have to be organised with the way you lay things out, because it does look like a mess, I'm not going to lie. It looks like an absolute mess. However, because I understand what I'm doing, it's clear to me, and the way you lay your work out should be clear to you as well. So what does this mean I need to do? I need to do 2 u to the 4 v to the 5 times by a to the 3. So that would just give me 2u4 v to the power 5 times by a cubed. So I'll just write it all together, because remember, when you put things next to each other in algebra, it means that we're multiplying them. Over 3 times 1 is 3, and then we cancelled everything else, so it's just 3. The only thing we have on the bottom is 3. and that would be my final answer. Nothing else can be cancelled there. And again, if you'd rather, you could have just multiplied across and then cancelled. Okay. Which I'll show you now. I'll do that method and we'll finish on the method where I didn't cross cancel. So if I just multiplied across, I would have got, if I didn't cross cancel, you'd have had 10u to the 5, so 10u to the 5, v to the 6, times by a to the 5, over 3a squared times by 5 would give me 15, a squared, u, v. And now this is just a simplifying, like the starter indice question. We've got 10 and 15 would cancel to 2 over 3. We've got u to the 5 and u to the 1, so you take them away, so you'd get u to the 4. You'd have v to the 6 and v to the 1, technically, remember, so taking those away, because the rule says you minus them, would give me v to the 5. And then you've got a to the 2 on the bottom and a to the 5 on top, so 5 minus 2 would be 3, so you'd have a to the 3. And hopefully that is exactly the same answer. So just remember, this pink bit here is just without cross cancelling. So you have to have a really, as you can see, you have to have a really, really solid understanding of basic fraction understandings, operations, indice laws. Cross cancelling is really useful. And they look hard, but once you start to practice them, and that's the key, you need to practice, they become quite straightforward. They just look a lot harder than they actually are. Okay, so hopefully you managed to follow along on those examples that we've looked at. And there's some practice questions for you there. My advice for you would be from 3 onwards, use BIDMAS. Okay, like the brackets would have to happen first and then you do that division. And if you check the description, there are even more examples that you can practice. If you're finding the ones that I've put here tricky to begin with, if you look at the ones in the description, they start a lot easier and progress. But that is your introduction to algebraic fractions. In Algebraic Fractions 2, we'll be looking at how do we add and subtract algebraic fractions, and then we'll progress into solving and ones where we have quadratics. So thank you for watching. Hopefully you learned something, and I'll see you in the next one.